So, hey folks, thanks for tuning in. It's an honor to have you all on our show. And thanks Supriya for hosting the show. Means a lot. And you can give the
And
intro of your
thanks you
community
too.
and just move ahead. Yeah, perfect.
Yeah. Hello everyone, I'm the new organizer of Azure Developer Community. I'm very excited as this is my first event I'm going to organize after taking up the charge as organizer. So I wish you learn something from this session. And also I want to tell you about something about my community. The main motto of our community is to help the local developers and also the techies who are interested in by providing the resources and also encouraging their interest. It's not only for the Warangal people. If you are interested in to join in our community, we are here to welcome you into our extended family. So here comes our today's speaker, Vishwas Narayan. He is also one of the Azure lead with brilliant knowledge of the machine learning
I
and
don't have brilliant
also
knowledge. Nobody has it. Don't worry about that. So
okay.
yeah, folks, I'll just give a quick intro about myself and we'll just start off with the session. It's a quick intro. I wanted to be a researcher. I want to always work in terms of like how many models can I build? How many of the models can I break? And this is what my experimentation is all about every single day. I just look at like what are the parameters, what are the hyperparameters and the things like that. And we write some papers. So this is what I do. And if anybody wants to write some papers or anything you want as a guidance, do reach out to me back. I'll be there for you guys to help. And Lakshita, I'm sharing my screen entirely, so do share it off. So let's just go ahead. So yes, I think I hope the code of conduct was not seen. I had wrote it for my one of my teammates there. So just wanted to play with them. That's it. So yeah, let's just get it started. So yes, I'm in a proper setting and perfect. So deep learning, the new buzzword and the new key for the enterprise edition of software and the hardware that we are talking. So there is always a two dependent factor that we are taking care here. So it's always two dependent factor. One is always a software and the other one is an hardware, and there is always an trade-off that these two play. So this trade-off led to more amount of statistics to be pulled out, more amount of work to be pulled out in terms of deep learning and the AI and what we are thinking. So this basically is dependent on data. This basically is dependent on the compute, and this basically is dependent on the form factor of the data. Like it can be anything, but until and unless you're not annotated it properly, it doesn't work. So in a brief note, we'll also run through some code, we'll also run through some demos, we'll have a complete sort of an introduction with respect to all different aspects that we are covering here. So this is what a brief intro about it. So let me just give you a quick intro about like where did this neural network and all these things started, because we'll be moving ahead with an advanced level of algorithms, we'll be moving ahead with an advanced level of code. Yes, today I have not done anything advanced in terms of like data set or something, but I'll be explaining you some sort of a code on a Azure Developer Community channel through some notebooks and the things like that. So let me just draw a simple neuron. How does this communicate and the things like that? So it's a nucleus. So there is a different set of cells that goes through. So there is an body. So there is a myelin sheet, and basically these have a lot of dendrites, and we also call it in terms of harbor and things like that. So it's always there. So what happened was there was a sort of a communication which happened, and to be very frank, there is a lot of chemistry involved here. So between this dendrite, and let me just copy this entire image and just paste it down here. So between this neural network that I'm talking here and with respect to this neural network entire scenario that I'm talking here. So there is always an electronic motion that goes through. So there is always an electron which just moves out from here to there, here to there. So there is an electron which is communicating, and the medium through they communicate is called as acetylcholine. So don't worry, this is not a biology class. I'm just giving you a quick intro. This is a sort of a communication that we have. And now, over a course of time, we just have that introduction like, hey, let's just build a piece of silicon and as an electronic circuit. So basically what you are just trying to do is you are just trying to build a circuit out of all the things that you're trying to build, and you're just using the simple techniques of VLSI and the fabrication to do so. Like, I can say you a quick intro about one of my notes that I do on deep learning. I'm very proud of showing this notes because I have a good amount of notes, by the way. Yes, yeah, you can see FD soy has been given here, and you can see how I think my handwriting is good. So is it good? Don't judge me. I think my handwriting is good. So this is a sort of an intro that was always going through. Like, we use the same old CMOS substrate or the SD soy substrate or something, and we just try building a brain. But this heavily dependent on what was the requirement of the software. So software was there, and some great man just knew how to just do that. So he started it called as a perceptron model. So he just tried building a neuron. So Rosenwald, there are other scientists who just know that, hey, if you put an silicon substrate with some sort of a function with x and y, like x1 and x2, let's just keep that. So f of x1, and let's say the function of it is just going to be there. So let's say I just want another output, f of x2, and things like that. So this is how the system evolved. And if you are an ECE folks, you would know something called as a control system. And I did the same mistake of taking it with a lot of passion and then regretting it. So don't do that. So take computer science and never make a mistake like me. So control system works on the same principles that we are talking here. So whatever you see here works as the same thing. So f of x will now have a variable and will now have a separate set of an output based on the definition. And also it's also dependent on like what kind of a function is it. Like if this is a summer, what it does is f of x1 plus x2. And if there is a summation added to it here as well, so there is an f of x1 plus f of x2, a kind of a functionality that we start deriving, and we start recognizing that, hey, we evolved from this complexity till here. So now how do we just join all of this? So basically what it started was like everybody knew that we know how to draw a graph, an x and a y variable. I'm not taking 3D. 3D is very complex. What we have to do in 3D is a lot of a tensor calculation. So I can't teach you tensor calculation in an hour. Sorry for that. It's so complex. Like it took me almost 3 months to understand it, and I got 3 out of 4 score there. So it's pretty bad as well. So we still have guys who scored 3.6, 3.7 in that, and I'm not that genius. So let's say, okay, there is some sort of an dependent value. This is an independent value, and this is an dependent value here. And this is an independent value that you're going to add. Like, let's say this has some sort of a function here, this has some sort of function here, this has some sort of function here, and this has some sort of function here. So what people started doing was they used to just do it mathematically, and they just started connecting the dots. And connecting dots gave them a lot of insights, and everybody thought, so hey, this part here looks like a straight line. So let's just note it as y is equal to mx plus c. And this part here also looks the same. And if, let's say, if there is hundreds of points that are plotted randomly, they all still plot as a line here. So let's just modify that and start working it. So now what happened was the same old principles of and control system that we just saw here, like how does a function move in inside a silicon substrate and things like that. What they involved here was the same old neural network and the same old silicon substrate. This is the magical substrate. Like magic starts here. And what they really meant to do was, let's just give a set of inputs, n number of it. So n to 1. So 1 to n is what we started. And you know what? Let's just quantize it to an extent where we can, if we are getting a value which is like 100 and 99, 98, 95 point something or something. Like let's say this is the threshold value, 100, and this is very less, this is very less, this is very less, and this, let's just set some standardization and let's just start doing. Like let's say if the points are till here, it goes to 2. If the points are till here and here, let it be 1 or something. So what they started doing was they started putting in some sort of a bias, and they started quantizing the models. The quantization of the models is very simple. I'll also show you some papers, also show you some mathematics which is there. So don't worry about that. So they started adding that bias, and they knew that this is going to be still going to be an f of x. So what they did was they noted the output as y is equals to b plus mx plus c. Like let's just say some sort of a constant or anything to be added in order to quantize it. Or else you can say, let's remove this and let's start working. And this was a kind of a functionality that was derived. And the biases, the weights which you can add. So I'll come to weights a little later, but understand what is a bias. Bias is just a variable that is going to quantize your model, also quantize the input data for the required infrastructure. Like something like if you are quantizing hundreds of data which are very close together, it's like 99.9999, 99.95 or something. Let's just put it to 95. So this is where kind of a bias makes its functionality available. And weights are something like, you know what? Let's just add something called as a weights, and let's just make it that constant. And so let's say something like you just get a value of 1.25. It's like you're just a CGPA calculation. It's like percentage divided by 10 plus 0.75. That's what you add, right? That's what your CGPA calculation is. A kind of a calculation that you can do. So this is what they extracted out from that information. And it's all solved with that philosophy of like, we have this amount of information, how can we reach out to that? And this is what your entire infrastructure of neural network started. This is just a model of a neuron, and scientists went nuts and they started joining in as many neurons as they can, and they named it as an input neural network layer, output neural network layer, and this is the set of an hidden layer which does a lot of magic. So it's still the same old mathematics that it still uses, but it's still going to be a little complex when you still compare it with. So they started connecting each of it. Connecting each of it made it much more easier for them to understand, okay, there is a set of neural network which can start communicating with entire infrastructure. Let's just do that. So if I give x1 and x2, it gives y1 and y2. And this is what really led to the magic of the neural network layers that came into the picture. So if you I'll explain you how the neural network architecture is as well. So when you take this sort of an consultation and this sort of an infrastructure that can be coded, and you can start comparing with this, what this does and what this architecture does as an infrastructure written in software or the hardware still did the same thing. Why can't we just had some sort of a feedback? Because in sort of a control system theory, there is a system, this is a black box, and nobody knows what's inside a black box, and we consider this based on the inputs and outputs. So we just have that. So now there was a scenario where, let's just make sure that if we face a noise here, so let's just add it up to something here. So let's just add it up to something as an filter or else any sort of a bias element and things like that, and just lead it back to the input itself. So that this is what was your feedback loop for your entire control system panel was all about. So they saw that and they told, why not implement it here? And they just went nuts again and they told, okay, let's just go back and give back these as an inputs. And it can be an input neural network or else it can be some sort of filter out there, and you can do some addition, subtraction, multiplication, whatever it is, you know, you can do anything. So this is what your back propagation is all about. So simple neural networks are just the connection of software layers which get some weights, biases, and they're quantized, normalized to an extent where they can give some insights out from that data. That's it. Simple as that. If you don't get it, don't worry. Just stare at this neural network. You get this definition of it. So let's just go back to the, what you can say, Google mathematics of deep learning archive is what you can go and check. And this, I'm not joking. Just go back and study this. This is one of the best thing that you can reach out to for the mathematics of deep learning. So why I'm saying you require a mathematics of deep learning, it's because, like, I think there's a book from Pact. I think it's Jadvi or something. I didn't read that. Sorry for that. It's an amazing book. I read some pages out there. I just read some formulas. It's an amazing set of collection of formulas and the things like that. So let me just show you one of it. So this belongs to everything. It's always still the same. So you get it in all the papers. It's like n number of units and the things like that. So you'll always still have it. You still have the summation stuff. So summations still exist in your calculation. So you need to know that. And what I was saying about was the simple kind of a neural network. They just gave you that edge here. Like, you guys can see that, how big of a neural network can be. And look at the fact that they are still used annotations here. So that pre-activation function, everything, that's just functions only. Don't complicate it. It's just still functions. It's still there in your neural network and they still move on. So this is a sort of a definition that we are looking forward to. It's just a quick intro. I'm not giving you anything. If you want an amazing intro, wait, I have a slide. I can share you that as well. So I think I do a lot of slides. I have missed it out somewhere down the line. Wait, a deep learning mechanism. What is that? So it's not crash course. This is the one. This is the okay. Okay, I was just hired for some university to give a TA for bachelor students, so I just wanted to do that. So you can see all sort of an annotation. I'm not yet completed these slides. I'll just share it off with you folks so that you guys can understand. So activation function, everything, we also don't get that instant understanding, like, hey, this was the equation for it, and we start fiddling around with all these neural network architecture and things like that. So don't worry about it. It's just a set of inputs and outputs that is getting mapped here. So yeah, I think I have a pretty good amount of slides which can teach you the basic mechanism of it. So don't worry about that. Still, whatever I'm teaching you is just a quick intro, just for giving you that uptime for all the things. So I hope you don't have any questions. So hello, I'm interested. Okay, everybody is interested. Can't help that. So this is a simple link. I would share it to you guys. So just go back and check it out. So it will be there in the private chat. They'll put it in the comment section out there. So let's just go on with the AutoML and the things like that. So it's running. So let's see what happened. It's still running. It's still running. It might take an hour or so. So by the time we come up with all sort of an explanation, probably it will be ready. Let's just go ahead. So very simple. You guys go back to the portal.azure.com. Simple as that. You just go there, click on something called as machine learning, and as soon as you click on it, you get this pop-up saying that, hey, machine learning is still available and To be very frank, there is also something called as data science VM. So you guys can look at all the options which are still available here. So all these options are for the Azure infrastructure. You guys can access it quickly. There are NVIDIA drivers that are optimized for your neural network architecture. To be very frank, you can have something called a spike CUDA on your entire infrastructure, and you need not have to do any sort of an optimization using the CUDA codes and the things like that. Like this works like a magic. This works like a magic. Some of the people are doing that, so you guys can see that like how good of an infrastructure is Azure. So machine learning, if you can go here and click on that machine learning, you'll be getting a blank page. So just go to the create here. So when you start creating it, those services will be automatically adding a lot of key vault and other services. I'll show you that as well. So you guys go here, click on it. So create a new one too. Was always there. So new one was there. New one two was not there. New one two space. Oh yeah. So space is already created, none of it. I don't want any sort of container registry allocated right now. So if you had created some sort of a container registry, you guys can go there. So for those people who don't know what is a container registry is like the Docker hub on your Azure infrastructure. So it just collects all the images that you're containerized. So containerization is like packaging of all your code and just pulling it and pushing it to one repository where it can fetch in the data and it can start working as smooth as anything in any platform. It's platform agnostic approach. So review and create. So it will start creating. So let's see what's going on here. So there is if you see that there is always a storage account, key vault, storage account, key vault, workspace name is always there. Application insights will always be there. If you have given a registry, there will be a registry out there. So you can see that how well defined it gets. You need not have to do much. All your secrets are safe. All your information is safe. This to me is a sort of an ultimate introduction to the governance and the security. So if you want to do DevOps, this is what it is. So it's an end-to-end MLOps pipeline as well. I'll show you one which is also there from the Databricks as well. So similar infrastructure that you can see, but a little bit of changes here and there. That's it. So you guys can do that and check out what is happening. And fun fact, there is networking. So public endpoints are always there. So as soon as we enter through all of these infrastructure, there is always a need for you to understand, okay, why is this network required? Because a lot of times when you are working on amazing problem statements, what happens is some people want to really get that information. So they hire the hackers and they get it in. But as long as your credentials are safe and sound, you need not have to worry about it. So this is what it is. So, and all of it system assigned, Microsoft managed, and disability. So yes, it's always done. So it's now starts creating. So already created ones are there. So I'll just show you how these are there. So you saw that, right? You know how the ML services are there. So there are two ways to enter the studio. So it's always there. So ML flow tracking URL, this is like you just have a version of MLOps just de facto built on your system. So you need not have to worry about it. So application insights gets its name, key vault gets its name, and so on. So it's all that. So that infrastructure was already created. So let me just launch the studio and see what's happening there. So it stays status running and perfect. What it has an entity is very simple. It's compute instance provision. Let's see what is being provisioned here. So yes, so compute is provisioned, so it's running. So it's very simple. I'll just show you one by one. Don't worry about that. We can start working on every problem statement that we're looking forward to. So you will be in the home and you will be having the recent resources and the runs. If you have run it, if you have not, this two things will not be there. So you'll have an entire blank notebook. And what you can do is you can look at it. This is for the notebooks, this is for the AutoML, and this is for the designer. So it's under the home repository, and if as soon as you click on it, you'll have an entire infrastructure running for you. It's simple as that. So this is notebook, AutoML, and things. So let's just learn what is AutoML first. So AutoML, I'm still running it. So let me just show you how to run a new AutoML instance as well. So very simple. For machine learning, you need data set. As always told, X1 and X2, everything is still a data set. You still need a data set. So let's just choose from the open data set. Web files can be added. Like if you have some web files, like it's sort of an URL downloadable. Instead of doing the curl and everything, it just does the simple way. In database store, if you have it in the database store, we'll also show you how to create that. But you can add from the open data set and start working on it. So let's say I've used a MNIST database of handwritten or something. Like let's say this is the one, and you can see that, let's just choose diabetes only. So sample diabetes, I have chosen it. So let's just click on the next. So data set name, which was new trial, is what I created. And let's see what happens with this data set. Right, successfully added. So now refresh it. So you have the new data set created for you. So you guys can just happily access all the infrastructure, which is just there on your Azure infrastructure. So you need not have to worry about it. Show supported data sets only. If you just unshow it, it will show like all the unsupported data sets like XML, JSONs, and if you have added it. So it just shows the supported data sets. So now let's click on that. And as soon as you click on that, you'll have a preview of it. It says that, okay, age 59, sex is 2 ka matlab it's female, sex is 1 is male, body mass index. So if you don't know what is a body mass index, index is here. So this is a sort of a graph and everything, they just have that. This is for the biology folks and the biotech folks who really want to just get in there. So BP is the blood pressure, S1, S2, S3 is the values that are interdependent on all those things, and Y is just saying that, hey, what will be the diabetic level and how much is the diabetes going to be there. And you can close it. You can click on that, like it's that show button which comes there, and if you just click on it, that data set will be created. So you clicked on that. So now, simple thing, you can use an existing experiment, but since you will be doing as a new one, so a new beginning. So let's just do that. So let's just do new beginning. All right. So there should not be any spaces because the experiment name is 1. So you guys can give underscore and start working with 1 or something, or else dash or one thing that works. So simple as that. You need not have to give any space here. So if you start giving any space here, they will not start working. So perfect. So target columns, it knows that there was a column which was there. Earlier, if you see that the data set was not being that analyzed, you were supposed to set which column you had to choose. Should there be headings or something like that? Today it's like so automated. Like this is cool. So you guys can start checking out. So, okay, let's just say I want to study for X number of parameters, or X parameter is what my input would be. And I would give compute instance because I want compute instance to come up. So let's say I want to run this. I'm running it. And as soon as you know that, it's a kind of a data set which is required for the regression algorithm. And it knows that I need to put in my infrastructure in a regression algorithm instead of it just crisscross the entire infrastructure that is required for classification. And it's not a time series forecasting because there is no set of times which is given. It's just the age which is given, which is not a time at all. It's something like if you say something like at 12:25, this is what happened. At 12:26, this is what happened. This is what it should have, but it's not giving you out. So lucky me, it's all working fine. And validation is some sort of a step where I need to explain this on the whiteboard. Something like you get this sort of an input and the output strategies, and what you just get from here is .h5, .pt, .pmml, .json, or else .xml. Like, this is how we export the model in the real world as well. So you get all these, and you find that it has been trained on this amount of parameters. Let's just test its strength on a new data set, a new data pattern. So a new data pattern will be analyzed. There will be a new set of data, and there will be a new set of inputs that will be triggering the probability spike. It's still probability, it's still statistics, but it's still going to be a sort of an electronic signal that is taken care. So this is what the philosophy behind that validation was all about. So a new input, how can it validate? So let's say if there are 100 number of inputs and it successfully clears out and says that 75% ka matlab 75 of it were right and 25 of it were wrong, that means that this model, for a new set of data set, it has an accuracy of 75%. And this to me is an ultimate definition, which is just going to be like, hey, how can we really start moving with the entire infrastructure? How can we just move ahead and make sure that this model can be deployable? Ka matlab, hundreds of people can use some of the insights. It will be still be the same amount of X and of Y inputs and outputs, but will it going to give us that value out in the future world? And there you have it. So this is where your validation comes into the picture. So it's still going to be that entire machine for our structure, which still require what should be my trade-off that I should be looking forward to, how much of data, compute, the form factor of the data, and the things like that. Still knows that neural network mechanism, and still works as a control system, which is still going to be that black box, unknown to any person, still going to have that mathematical approximation, and yet evolving as soon as you give the data. This is what your entire ML infrastructure is all about. So this is what they did. And I'm like, let it do automatic validation. I don't want to do anything. I don't want to do k-fold, Monte Carlo cross validation, train test validation, and things like that. So let's say, what is this Monte Carlo and the k-fold? So k-fold is something as good as this. Let's do this. Wait. Google Slides, right? Slides is here. So I'll open that slide which I was looking forward to. I think I edited 8 days ago. I'm not getting the mood to edit that. So it's very bad from my side. So this is what your Crayford cross validation is all about. It's like you taking chunks and chunks of data, training it. Now you take the same chunk of data, try validating it, and you just have an iterations of it. So now what you just have is a huge set of data which is scrambled and which is picked here and there. There is no random noise which is added, but there is always that one change that is going to be experienced. And this is where your validation sets are coming in and leaving out the charm. So you can go to this entire link. You guys can check out this link as well. So where did I lose you guys? Oh yeah, you guys are here. So I think they have commented it out. All right. So that's perfect, folks. So this is how it is. So right now, what I want to do is, I don't want to do all this kind of mindset. I just want you to do everything. Just do whatever you want and just give me out the results. And I don't have to provide this. You know what? Just split it for that required parameters that you need. So automatically do one thing. Like you can really change those parameters if you want, but let it be 10. So let's just finish it off. So what's happening here is it's just running it. So now I started the instance. So what it does is it does a lot of validation. It does a lot of controls and things like that. And now it gives out that output. And now you can start doing anything with it. So it's not yet started. Let's see whether it starts now. So it's running, setting up the run. It's now initializing the compute instance. If we come back after some time, it will be running some other features out there and things like that. So do check out all the links that I'm giving here. So I think automatic epic run, it's already started. So if you can see that there's already a notification orange. So if I do this, there's always a notification. It says that, hey, your AutoML run is already active. Click on that run details, you'll come back to this page only. Or else you can go back to this experiments. You can see that, okay, now we had this many amount of experiments done, and what next? Let's see if this has been completed. I think it's still running. Let's see. In a later part, I'll show you how to deploy, how to get the swaggers, how does the swagger work, and everything. So if you can go to slides, Google Slides. So, oh, sorry, folks. I just have that very bad habit of not clicking on proper links. So I was very lazy. I don't want to do any slides for this session. So I just took out some things and I started working. So what I told about the swaggers and the APIs will be in the form factor of a not a neural network, an URL. Sorry for that neural network thing. So whatever you give as an input here, as in data here, like let's see this. So whatever I gave as in data here, so I just gave something as a data here, and now this started working fine. So this was what I wanted, and data, and it immediately gave me some sort of an output and told me that, hey boss, you know what, there was a new glitch which was being added. So what we did was I took the data in, but it was not valid. If it was a valid thing, it would have given me some sort of an output. So let's just see that as well. And if you can see that in this slide, I'm just portraying like how much of a compute instances was being run and how much of the usage, how much of the quota happened. And it told that, okay, 4 cores out of 6 cores were being used, 2 cores out of 6 cores were being used. So it also defines how much of a compute efficiency you have. And lastly, it's all about that information that you're going to gather. So I think this is going to take this is going to be easy because it's going to be a little earlier than what I could have done. So I think let's just move ahead with it. So right now, don't worry about it. It's just a simple thing. So very simple. We were talking about the compute instances and everything, right? The compute instances are very simple. You just have to just go there, click on the create compute instances. If you don't have any clear instances, you have to click on the new. And as soon as you go here and type in something that is required, you just get that compute instance, right? It's now being created. This is the simple step. You just can see how much different quotas of compute instances are there. Like you can see, as soon as I hit on the CPU, this CPU will have different amount of versions, different amount of compute instances that can be given. And this talks about memory optimization ka matlab, RAM can be optimized. General purpose, it's like it's just throws in as your regular PC, which is not optimized for anything. So compute optimized is something like, it's more efficient in terms of using all the cores. It's like the quota is always there. So to me, it's like 278 cores which are still available. I think I can bash with it. So don't worry about that. So it's like extensibility, like how much of an instance can you scale up to. So let me just click on the GPU. So you can see GPU Tesla K80 is available. Tesla M60 is available. So what is all this Tesla thing that we're talking here? Tesla K80 in Google Colab. So you guys can go check out how much of an Colab notebooks are available. So Tesla architecture is something like very easy to be used, and they are going to be much effective. So if you click on this command here, NVIDIA SMI, so let's just click on it. So just click on this and just type in this entire code with an exclamation mark, NVIDIA SMI, you will get all the information about the compute instance which is available. So very simple. If you are very good, there is something called a paper space. Jupyter notebook, you get a GPU assisted one, and you get amazing notebooks which are already there. So sign in and just to start working with it. So you are good to go with it. So you can log in with Google. I don't want to log in with Google now. Sorry for that. It's going to take a lot of time. So now create it. You will have a new compute instance which will be running. So very simple. What you can do is you get all the instances of VS Code. Okay, so it's now connected to the VS Code that I have right now. So installing it. So it will now start installing it. Trust workspace. Yes, I'm going to trust that. And see, it's installing the machine learning installation. And it will, of course, ask me for that. So I don't want to do that here. So let me just do one thing. So let me just go to Jupyter Lab. So as soon as I click on something called as a Jupyter Lab here, I'm now being redirected to a new tab. So very simple, it's very simple to use on this entire infrastructure, which is already being governed to this extent. You get your ultimate URL. If you can see that, it's Vishwas Narayana RE, which is my subscription. It's my location. It's saying I'm supposed to be running on an instance. Azure ML.ms is Microsoft, and lab is always there. So what you see in your Coursera is also this. So there is always a compute instance which is allocated for you, and that's a VM that you are running. So simple as that, you can still run Azure ML VMs. Like, let's just do that. Okay, let me just say import and import scikit-learn. I think it's not yet connected. Of course, it's connected. Import scikit-learn. Scikit-learn. Sorry for that. So import scikit-learn. It's just doing the same old imports, and it's now started to work. So import scikit-learn. Did it work? Yes, it should work. Yes, it started working. Import. Let's say import Azure ML. Like if I do that, oh, it did that. Oh, ML SDK was there. Import Cogno or something. Like there is no module, so it still works the same way. So compute instance is just like that direct connection that you are going to get for your instance. Like it's just connected to some sort of a network, and that's what it's running here. So it's running some sort of a job. It's running some sort of a job. It's a job running thing. So let's just delete all of it because it's going to cost me a lot. I just did it for the sake of it. So I need not have to do much of a work here. So this is what it is. So all these kinds of an instance will start working, and you can start working on any sort of an architecture that is required. So designer, on the other hand, is a very, very crucial step. I'll show you how this crucial step is. So let me just say I want to do some DenseNet wala stuff, and it just gives me that entire introduction to it. So let's just do that. So you can see that how much of an introduction has already happened. Like it has given out all the components to me here. Like everything has been sorted and everything has been done. So if you think of environments and pipelines, these are some amazing tools. We'll just go on in the future, but now explore this. But you can start running it, and this is going to work absolutely fine. And I think auto save is on, not yet started. That's perfect. Submit, publish is not working, so that's fine. It's just a plug and play thing. Like this is not used in entire production system. Production system is different, but if you see that, this is how they are working towards, and they are very close to an approximated value. So let me just go to already created ones which I have in my entire experiment. So I had it done. So you guys can see that it's already been completed, and it knows that, hey boss, you know what? You did amazing job here. No scores improved even after 20 iterations. So this is what an auto ML is all about. So data guardrails, it's something like, okay, I just have some sort of a models. So how can I use it? So all the models were there. And if you can click on it, it will just give you some sort of an explanation and gives you the information about the hyperparameters. So what's an hyperparameter? It's a very simple thing. It's just an optimization code that has been enabled for you. And that's it. So what's an explanation? It's not there, but you guys can go check out different models which were already being built, right? So you can see that like, hey, there was an 72% accuracy which was already there. Mean absolute error was this much. 46 point things, and everything is just neural network parameters that has been told. So yes, I think that's one of the thing. I think view explanation, you can see the view the explanation which is already there. It says that, hey, what happened to your entire matrices, at what time did it start running. Oh, okay, that's not a problem. So you guys can see that how much of an explanation happened. So test results given out here, so it's told that, okay, there's this amount of accuracy and this got completed in 3 minutes. Perfect. Outputs and the logs it's not giving me, but you guys can check out, like, this is like ultimate thing. Like, if this entire subscription was working, I could have shown you, but they didn't start working. I don't know why, but like, let's see if any of this starts working by then. It's just there. So I want to show you guys one of the notebooks that we wrote. If you guys can go check it out, the tutorial ones. Regression, AutoML, image classification is always there. So how to use Azure ML, that's there. Perfect. Like, let's see what happened here. Wait, it's too much of a thing here. So create first Azure ML, compute instance, everything is here, but like, why it's not giving me that notebook? I lost it. No. It's still there. So you guys can go check it out, what is happening here. And that explanation is always there. So that's cool. Why is it not giving me that notebook, man? Fine, that's perfect. You guys can check out how this subscription invite. Oh, okay. Since this subscription got done, it's not there. So it's a similar thing. I can show you that as well. Don't worry. So all these things like hardback permissions, everything is there. So let's just do that. So let's just grab in a template, clone it to our repository, and you can see the magic of it. This has an end-to-end pipeline which is already built. Like, you need not have to worry about anything. So it's already running, right? So let's see how much is this. So let's just do this. Compute instance is running. Oh, I don't want to do that. Sorry for that. All right. So if I go on connecting, continue here is perfect. So it takes time to just get you that instance. So compute instance deleted successfully, that's perfect. So if you can start running it, it will now start storing in all the endpoints and everything so quickly that you will be like amazed about the fact that this is going to be happening. Like, let's do this. So let's just run this. So it's a simple MNIST stuff that is still existing and everything is sorted here. Stop compute. I'll just stop it for a while and I'll start running it. So it's queued. Script modest is running. So it's saying, right, it's still running. So yeah, that's what it is all about. Like, it started running all the Azure infrastructure and it's just getting all the inputs and outputs for me. So perfect. This is like the ultimate thing that we really wanted and we are achieving it. So this is how it is. So a simple introduction that we just did, you guys can do any amount of it out there and do check out everything that we do here because we do a lot of stuff. So let's see whether this has been completed. So model training. So if you want, I can stop this entire thing. So cancellation is current progress. It may take 2 minutes to take effect. Yes, perfect. So it's been cancelled. But let's see what's happening here. So data guardrails are there. So I had some models which were built, but no explanation is available for this. Sorry for that. But let's see how to deploy it. Very simple. I just clicked on a model. Very simple. Let's just go here. See how much was the experiment. So let's just not worry about that. So let's just go this. So I had this BMI target. So BMI target got cancelled. So very simple. I had an experiment. I had an training compute instance which was already running. And now I went to the data guardrails. It just went and said me, hey, status has been done, validation split, handling, everything has been sorted. So data guardrails stays how much is the deployment and the stuff. So now you see that, okay, 100% of the sampling, normalization, root mean squared error, it's always there. So this is one of the parameters. So I can't teach you entire machine learning, sorry for that, but you guys can start working. So it just showed some outputs and the logs. Like it just gives you some sort of an JSON values like this, and you can start working like, hey, what happened to my featureization step and what really happened. So all these steps, what you're seeing on the screen was supposed to be written by you, but this was automated by it. So if you see some child runs, you can see that, hey, this is what happened, and this is how much of compute instances were there. So what happened in that backend of creating the same old BMI target, it now had different amount of compute instances. And if you see snapshots, snapshots are not available. So let's just go to a model, deploy it. So it's very simple. As soon as you click on this BMI target, you have three options. Just go and click on this model and you're good to go. And you now know that, okay, this is how the hyperparameters looks like. Perfect. Alpha, very simple. It's just the opacity of the model, which says how much of a transparent of the model is this. And this is good. Let me just do a web deployment. You'll see how the swaggers and everything will be created instantly. So Lavanya is my sister's name. Kubernetes service, that's good. Lavanya. Okay, I'll write my name by my sister's name. Compute name, let's say compute name required. So Vishwas. Enable authentication is container instance. I think container instance, if I do that right, I don't have to do anything. Use custom deployment. I said, nah, just do that. See, it just told you that it's a no-code deployment. And now you will have an endpoint. I'll show you what an endpoint is. So if you just go here, you just click on this. Now you have an endpoint. And you guys can go and see here, like it's now being created for that compute instance. Now, if you just wait for a time, you will have an endpoint deployment in progress. So now, as soon as I do that, you will see the magic of it. It just has a unique deployment which is already done. And that another endpoint was that MNS thing. Wait, I'll show you in the notebook what's the status of it. Quick start Azure ML. So it's here. So you guys can see that, right? Oh, sorry for that. So I think I need to validate somewhere at some point. I'm supposed to validate something, but it didn't validate. I don't know why. So let's just go there and check out what's happening. So whatever I told about the ML flow, this is what your ML flow will look like. So sorry for that. ML flow tracking URL is here. So let's just go on with this. So it doesn't work very seamlessly on some machine and some instances, but once you get the hold of it, this is going to be like a proper thing. So what you saw as an ML instance, it's now still there from this endpoint itself. So let's see whether this endpoint is being deployed or something. Vishwas is under deployment. SVC that happened during that time. I think this will take a little bit of time. Don't worry. Let's just wait for it. It just will happen. Or else automated ML run epic. Perfect. I think one of it has been completed. All right, so you guys can see that how much of an images were taken. So training confusion matrix was supposed to be from this entire thing, right? From this neural network. It now ran completely. And it gave me some sort of an outputs and the endpoints. Let's see that endpoints, if it gets deployed, I'll just show you that. So this is what it is. So anytime that you think of all these kinds of models and things like that, best thing, it's just going to be automated. Worst things, you will not get to know how's the magic of it. So to be very frank, we also try to make sure that we learn a lot from that entire instances and the things like that. So we do that. So yeah, swaggers are already here. So very simple. So if I just click on it, list of the index ranges. So you guys can see that, right? You know how much of an deployment happened. This is a Swagger URL. So this is a Swagger URL which is saying, hey, you guys can use it and start deploying the model. And it's still going to be the same old script of post, get request, and the pull request, and everything will be sorted for you. I think that's it, folks, from my side. I think, would you like to share for the code? I don't think I did anything as a code here, Tarun sir. You know, I just did something which is just a quick intro for the ML. I didn't do much of the thing here. So there's no GitHub here. Just go click on that link. You will get that entire ML infrastructure built for you. So I think that's the end of the session, folks. Thank you so much for being part of it. You know, we did till the deployment of the model. This is the best part about it. Like just one click and I had the model deployed, and you can start using it on the webhooks or else any sort of an pages that you really want to deploy it to, and everything is sorted for you. So you need not have to worry about it. I think that's it from my side, folks. Thank you so much for being part of it. Any questions and queries, do check it out. Do reach me out on LinkedIn, so I'll be there for you folks. So, Supriya, do you have anything to say? I think Supriya, you have anything to say?
Hello, am I audible?
Yeah, you're audible. Perfect.
Yeah, please provide your LinkedIn profile in the comment box.
Yeah, I'll do that. So it's LinkedIn, Vishwas N. So you guys can reach out to me at any point. So yeah, I'll just reach out to that.
You have
And
done a
I
great job.
one second,
Yeah,
I'll even give you a collab link, which has all the AutoML stuff. So you guys can go check it out, because if you are okay with not spending too much of money on Azure ML, there's a package from Flamel. You guys can go check it out. So it's in a private chat here. That's my LinkedIn. I'll give you the AutoML thing right now. AutoML frameworks worked. So that will be the name of the notebook. So you guys can copy that. You can start doing whatever you want. So first one is the Flamel notebook that I have written. So you guys can go check out this notebook. So if that notebook is not available in an URL, I'll do a tiny URL, tiny.cc, and that tiny URL will start working for you. Don't worry. Tiny auto ML notebook. So it's actually a tiny AutoML notebook only. So you guys can go check out this entire link. So this is the link for that notebook, tiny.cc, tiny AutoML notebook. So this is that ML thing. Sorry for not doing slides, because I don't know why I get so irritated to do ML slides today. Like one university is paying for me, I'm not able to deliver that slides to them. And the next link actually. So tiny.cc, tiny auto ML notebook. So that's the link, folks. Thank you so much for being part of the session, and I think we can end the broadcast.
yeah, Vishwas. Thank you so much for joining us. It's definitely worth for the beginners, and I also hope we come up with the advanced level with the
Yeah,
machine learning, Azure
what we'll be
machine
doing
learning.
is we'll take step by step. What we
Yeah,
just did was a complete introduction out of everything. We just tried teaching you everything in a time. What we'll do is for one day we'll completely do only AutoML. So
yeah,
that will be like a complete intro, so they can get to know end to end of it.
yes, absolutely. And I must say, you are such an active speaker. Yeah,
Thank you so much.
seriously.
Thank you so much.
Guys,
We can
guys,
end the
don't
broadcast.
think this is the only the session. We will definitely come up with the advanced level. Um, Thank you so much for joining us, Vishwas and the participants. Here the time comes to wrap up. So bye, folks. Bye, Vishwas.
Bye, everybody.
Yeah, bye.